with that, why don't I swing it over to you then, Daryl? Thank you. Putting you on the spot, but Daryl's got an excellent presentation in regards to Raspberry Pis and what you can do with them. I know in our configurations and amateur radio applications, it's just not putting a hotspot together with it or a ham clock. Those are two of hundreds of different applications you can do with the Raspberry Pi. So with that, over to you, Daryl. You do have share privileges, so take it away, and thank you very much for taking it on this morning.
Okay, Al, if you do see our guest speaker come on, just break in and I can stop at that time.
Yeah. Oh, and, yeah, okay.
This part, and then we can pick it up later, what I miss.
Sounds like a plan. Okay, thank you.
I'm going to go to the screen share. You can hear me okay?
Perfect, no problem. And we'll just get people to mute just in case there's background noise if you can. And if you do have a question, just unmute and fire away. Okay, thank you, everyone.
Okay, if anybody has a question, just if there's not too much chat, you can just break in and ask the question. If there's lots, just I'll try and pay attention to the incoming messages. Okay. So welcome to Raspberry Pi. I'm going to cover the Raspberry Pi, each of its connections, a few of the latest models by comparison, and their pinouts. And then I'll show some sensors as well as some projects that people have made with respect to amateur radio. Okay, Raspberry Pi is a single board computer. So if you see SBC written somewhere, that's what it stands for, a single board computer. Developed in the UK by the Raspberry Pi Foundation. They went in association with Broadcom, which is the chip that's on the board. Okay, the Broadcom system on a chip, SoC, it integrates, usually an SoC integrates as much circuitry into one chip possible. In this case, they've integrated the graphic circuitry with the CPU. Okay, the CPU itself is an ARM processor developed by ARM Limited and is a reduced instruction set computer as opposed to a CISC, which is a complex instruction set. Almost forgot what it was. Okay, was originally designed to teach kids around the world basic computer skills. To date, they've sold over 31 million Pis since it first launched in 2012. It has an extensive online support community. So if there's something you want to know about it, you just search Raspberry Pi with it and odds are you're going to find something. Okay, hobbyists and professionals quickly realize the Pi's potential, having a powerful processing ability, low power consumption, reduced weight, next to no weight, okay, small size, and low cost compared to a desktop computer. A good example of where Raspberry Pi has gone with all of these taken into account would be weather balloons. Putting a full-size PC on it is a lot heavier than one of these little Raspberry Pi boards. Raspberry Pis can be used in headless mode, meaning without a monitor, keyboard, or mouse, by accessing it via Wi-Fi or Ethernet from another computer's browser. It's capable of running many different operating systems, with Raspberry Pi OS being the most common. Raspberry Pi OS is a form of Linux, originally created as Debian. If no one's familiar with Debian, it's a husband-wife team, Deb and Ian, and they sort of rewritten a good chunk of Linux to run on a Raspberry Pi. If you like experimenting with different configurations or operating systems, with Raspberry Pi, you can easily swap out the micro SD card in a matter of seconds. So this will allow you to resort back to your original configuration if you had a working configuration for another project. Okay, what can you do with it? I won't read out the whole list, but I can make this presentation available to you. Okay, so anything from facial recognition, built-in Alexa, a photo frame or QSL card photo frame, doorbells that would include video and audio, airplane trackers such as AIS for tracking aircraft, or not AIS, I forget the term for it. AIS is for ships, but you can do that too with it. Anyway, it tracks their transponders via a software-defined radio dongle. So it'll be whatever's close to you. Okay, print servers, web servers, weather stations, retro gaming console, if you like the old Pac-Man and games like that. Menus, RFID programmer readers. You could use it to control CNC machines, Morse code transmitter, wearables. If you've seen any of the videos that have suits where it's all lit up with LEDs or L-wire, where the whole wire lights up the same color. Security systems, nutrition analyzers, drones, satellite detectors, you name it, you could build it to do anything. Okay, so the models that of Raspberry Pis that I chose to compare are the ones that are the latest ones that you can not necessarily easily get due to the shortages right now, but normally they're easy to get. 4B being the latest one is its clock speed runs at 1.5 gigahertz. It's a 4-core, 64-bit ARM Cortex processor. It's the first version of Raspberry Pi that comes with different memories on it. Unfortunately, the memories are soldered to the board, so you have to buy the board already populated with the size of memory you want. So it comes from 1 gig to up to 8 gig of RAM. Wi-Fi, it has both 2.4 and 5 gig, and it also has Ethernet at 1 gig, Bluetooth, and BLE, which is a form of Bluetooth. Okay, 2 USB 2 ports, 2 USB 3 ports, 2 micro HDMI 4K ports, memory card slot, which is a micro SD, which is what Raspberry Pi uses on all of their boards. That's not to be confused with RAM. RAM is your volatile memory, where it does all its work, and your micro SD is where it saves all of your information in your programs for the next time you start it up. That's where it fetches it from. Okay, other ports, camera, HAT compatible, 40-pin GPIO. So 3B is very, very similar, a tiny bit slower in speed, only comes with 1 gig of RAM, and Bluetooth is not 5, it's only 4.2, and a little bit slower on the Ethernet. USB 2 only, not 3, and only 1K HDMI. So those two boards are the same footprint when it comes to how big they are. It's about the size of a pack of cigarettes. The 0 is what would be in like a jumbo spot, so it's a fraction of the size. So the latest one is a 02W, which is runs at 1 gigahertz, 4-core, 64-bit ARM. So when they compare the 0 with the full-size boards, it's similar to the 3B in speed. Only half as much memory. No 5G on it, as the rest of it though. Bluetooth, same. No Ethernet port, meaning you have to plug on a board or a dongle, should say, that gives you Ethernet. And only one micro USB card. They took away a lot of the connections because of the physical space they take up. Only one HDMI, and it's a mini DMI, and at 1K. Okay, the 0W and the 0 are the same. And there's also a 0WH, just means that it has the header pins populated on the board. It's much slower, runs at 1 gigahertz, but it's only one core. Same amount of memory as the 2W. Has 802.11 for Wi-Fi, which would be your 2.4 gig. Bluetooth 4.1 only, no Ethernet port on any of the zeros. Once again, micro USB ports because of physical size, mini HDMI for plugging on a 1080p monitor, 1K monitor, and still has micro SD. The 0, like I said, it's the same as the 0W. The only difference is the W includes wireless, where the 0 doesn't have wireless. The Pico, I talk about it sometimes because it's also quite capable. It's not a microcomputer where all the others are microcomputers. It's a microcontroller. Being a microcontroller, the biggest difference would be you cannot load an operating system on it. It has an instruction set. It'll understand a couple of languages. Other than that, you have to work with what's on it. It's a fraction of the size as well. So it's a fraction of the speed. Okay, only 32-bit. RAM is only 264K, not much because it's a microcontroller, doesn't require much. It has 2 mega flash memory on it. And no micro SD card because it has the 2 meg flash. Okay. Here's a 4B. I'll start up on the left corner. So we have a HAT compatible. That's hardware attached on top is what HAT stands for. So this would be the top of the board and you would plug onto these pins. So that means each pin has an assignment, and when you plug a HAT onto it, it reads an EEPROM, and that EEPROM tells when the Raspberry Pi gets the address, it's supposed to know exactly what to do with that HAT without you doing a whole lot of configuring. Okay, right here is a little power over Ethernet. In order to do that, you need to plug a little board onto there, but it is capable of doing it. Next connector is RJ45 Ethernet port. So you can plug physically into the network. Down from there is 2 USB 3 ports, stacked one on top of the other. 2 USB 2 ports. You have a 4-pole 3.5 millimeter composite video and audio jack right here is what this is. Composite video would be more compared to a VGA signal. Next connector is this one right here, and it's a ribbon cable that plugs straight into in between this black and white section here. And it's a camera port that there's a Raspberry Pi camera. They have a few different versions of it, and it would plug into here without using any of your other ports. Next port right here and right here are two micro HDMI ports for 4K. So if you only had a regular HDMI connector and you wanted to plug a monitor on, you would have to get a little adapter or an adapter cable. Next one over looks like a micro USB, but it's for power only. There's no data connections on it. It's strictly for data input power, or sorry, input power, not data. Next one up is this black piece sticking out here is a micro SD card, and it's on the back of the card. So that's why you can only see a portion of the memory. Right beside it is a display port, different from the HDMIs. You could plug on Raspberry Pi displays that are also touch screens. As long as it's DSi compatible, it would plug right into here with a ribbon cable. Okay. Next one up is on the 4B is 2.4 gig and 5 gigahertz Wi-Fi and Bluetooth 5.0. Where that sits is right here in this silver box. It's shielded in a metal can. Okay, and that's the Bluetooth on it and Wi-Fi. You can see the size of it. It's not very big. I put the dimensions on there. It's what size of a cigarette pack. Okay, Raspberry Pi 3B. When you look at it, it's roughly it's the exact same size, but they've moved a couple of things. Okay, HAT compatible 40-pin header, still in the same spot. Power over Ethernet is still there. USB 2 is in this corner instead of the Ethernet. And here's two more USB 2 ports. And Ethernet is down here. So they swapped the location of the Ethernet ports. Next one around is a 4-pole composite video and audio socket, same as on the other, on the 4B. Camera, same as on the 4B. HDMI, this one is a full-size HDMI connector and only one connector. To the left of that, micro USB power only for power input. Next one up is micro SDs in the same spot. It doesn't show the card on this one sticking out, but it's right in behind here. Display, same thing. And Wi-Fi, same location as on the 4B. Next one is a Raspberry Pi 2.0. This is the HAT compatible header with no pins in it. If you buy it with the pins, it ends up costing about $7 more for somebody to solder a 50-cent connector on it. So if you're good at soldering and you want to do some soldering, that's the way to buy it if you want to save $7 a board. Or if not, you can buy it pre-populated with pins there. Come around to the end here is a camera connector. It's the same as on the 4B with the exception it plugs in the end instead of downwards on the board. Next one around is micro USB power only. Okay. Next one is micro USB 2. That's for your data. Right above it, we have the Wi-Fi module, and it's also Bluetooth on this one. I just didn't mark it off to change that. Next one around to the left here is mini HDMI. So if you wanted to plug it into your full-size HDMI, it'll require an adapter or a cable that adapts it. Next one around is micro SD card slot on the top side of the board this time. And that's where you'd plug your micro SD card. Next one is Raspberry Pi 0W, the version 1 if you want to call it that. Same thing. Header pins are in the same spot. Cameras in the same spot. Power's in the same spot. Micro USB's in the same spot. Wi-Fi is in the same spot. They just don't have the steel box over it. Mini HDMI to the left, and micro SD card slot. The big chip here is the CPU. The next one is the Raspberry Pi Pico. It's about 1 inch across the narrow side and about 2 inches the long side. Its header would be these pins all the way down one side and up the other side. It's not HAT compatible, okay? It has a lot of the same functions, but it's not HAT compatible. On the bottom here, it has 3 pins for debug. No Wi-Fi. If you wanted Wi-Fi or internet or Ethernet, you would have to plug in a card or something attached to the pins that require it, and if you were wanting that function. Okay. The USB connector is both data and power in this case. What does the Pico compare to? I put over to the side here. It compares to an ESP32, an Arduino board. An ESP8266 is similar to the 32. The big difference between the two is the 8266 was the first generation, and it never had this little circuit here, which is the Wi-Fi Bluetooth module, where the ESP32s all come with the wireless module on it. It also comes with a little more memory than the 8266, but they're extremely similar. And if anybody's familiar with the STEM32, it's a microcontroller as well. Meaning all of these have their own sort of language on them, and you program them through the through software that talks to the boards. Okay, so necessary extras that I determined would be good extras are, if your board doesn't have pins on it, you need pins. Okay. Memory, most of these boards come just as a circuit board. You can buy kits, but you have to make sure you know what's in the kit to know if you're getting everything, because different people, different companies put their kits together slightly different. So if you're buying in all the pieces yourself, these are things that you need to go with it. So you need a micro SD card adapter, card and an adapter depending on your card reader. Okay, mini to HDMI to HDMI, that's on the Raspberry Pi Zeros. In the middle, I have the micro HDMI to HDMI, which is for the 4B. Okay. To the left, if you needed on a Zero, if it didn't have Ethernet, this is the easiest way to connect to Ethernet or network. You get a dongle that's like this. It gives you full-size USB on it. Gives you an RJ45. You can plug on a network, all without having to load any drivers for that particular device. It just works when you plug it on. The Raspberry Pi recognizes it. On the right, if you don't have a card reader on your computer, you would need a card reader. The easiest way is get a USB dongle that gives you a card reader. This one would take the micro SD and a full-size SD, depending on on what you want to program. There are all Raspberry Pis use the micro though. Okay. A good reason for this full-size SD adapter is most of our radios use SD. Okay, Raspberry Pi doesn't come with a case. This is just a sample case. There are many different cases. It all depends on what you want to plug on your board. You may need more space. You can buy them or you can 3D print them. And of course, it doesn't come with a power adapter, so you need power adapters. Okay, power requirements, okay? All Raspberry Pi computers will take 5.1 volts DC input. Now, there is a range that it'll take, but that's what they're calling for. The input voltage for the Pico microcontroller is 1.8 volts to 5.5 volts. Power input to the Raspberry Pi 4B and 400, the 400 I haven't talked about before. It's a extremely similar 4B computer, but they only sell the board mounted in what looks like a keyboard. And it does everything a 4B does, but it's already mounted inside a keyboard case. Uses a dedicated USB-C port for power. Both the 4B and 400. All other Pis all other Pi computers use dedicated micro USB. For proper operation and protection, do not backfeed power into the Raspberry Pi into any of the other USB ports. It's not going to cooperate, and eventually something's going to break. You bypassed all of its voltage regulators and things like that, so they don't want you to backfeed it through the other USB ports. Main voltages used by the Raspberry Pi are 5 volts DC, 3.3 volts DC, and 1.8 volts DC. 5 volt DC rail supplies power to the USB port, HDMI ports, 2 of the GPIO, general purpose IO, that's the 40 pin header, feeds it to 2 of those pins, and to the onboard buck converter that in turn supplies power to the 3.3 volts and 1.8 volt rails. The 3.3 volt rail supplies power to most of the Raspberry Pi circuitry and to 2 of the GPIO pins. So I broke it down to where to find what each Raspberry Pi requires without having to search too far, and how much it draws. So a bare bones on a 4B would draw 600 milliamps approximately. It also depends on how much you're making it process at the time, but these are the typical values that each one of the Pis requires, okay? And I listed the Pico there as well. Suggested maximum USB current draw is 1.2 amps on a 4B, for example, in a 3B. So that means if you're drawing power to power a camera or whatever, they don't want you to draw more than 1.2 amps. It's potentially going to cause damage. So if you are going to draw more than 1.2 amps, what they would like you to do is provide it with its own power separately through another power adapter. The easiest way to do that, if it's a USB device, is get a USB splitter that has a power plug on it, is the easiest way to do that. Okay, so if you're doing your own projects, I listed how much the 3.3 volts GPIO pins, how much you're allowed to draw off of it. So you're allowed to draw 500 milliamps off of it, off of those 2 pins combined, not each, but combined. The 5 volt GPIO pins total combined is 1.5 amps. And they recommend a 3 amp power supply. Well, when you add all of these up, okay, it's going to be more than the 3 amps that they're calling for, but they don't expect you to be drawing maximum power from every thing out there.
Excuse me for a second, Daryl.
Sure.
I have a question. You're showing 1.5 amp. Is it, is the board fuse protected?
Yeah, as long as you're plugged into the power, the proper power connection.
Mm-hmm.
There's a fuse. It is thermal, meaning
Okay.
it will reset itself.
Yeah, okay.
Sometimes that fuse can take a day to reset itself, depending how hot it's gotten. And some people claim that if they didn't call it freeze mist, but that's what I call it, is freeze mist. You could use a can of compressed air. If you turn it upside down when it gets extremely cold because the liquid itself is coming out, the propellant, that also acts as freeze mist and you'll get frost from it. Some people have used that to reset the fused input faster.
Where is the fuse located on the board? Do you know?
Yeah, can I go back? See this 4R7 here?
Yeah.
I believe that is it on that board. And they don't label it on this one, but it would be this one.
Okay.
And on this one, it's one of these or all of those. I could be wrong. Is it easier to see on this one? This one's easier to see right here.
Okay.
Okay. And they're thermal resettable, and I forget the exact name of the type of fuse, but it can take 24 hours to reset. So it's not one that if you did something wrong and it popped the fuse that it's going to reset in 30 seconds. It's not. You have to wait for it to reset. Okay.